class, I showed you an example of writing a linear equation with 2 points. We visualized by drawing a drawing of the situation before we went through the algebra. Let's look at the problem. Write the equation of the line that passes through -1, 8 and -3, 5. So the first thing that I've done is plotted the points and drawn the line through. And this is the part where if you want to be a little bit more accurate, you can you can use a ruler, but please use white, non-lined, blank paper so that your lines do not mess you up and so that you can work on your spatial reasoning. So let's first look at the situation here. First of all, we know that this is going to be a line with a positive slope. So write that down. Slope is positive. Next, we're going to look at an estimate of the y-intercept. Okay, so this is an estimate. Y-intercept is approximately, and in class, Sasha guessed 9, so we're going to go with that too, so it's like what we did in class. Now we're actually going to start on the algebra, first solving for the slope by finding the change of the output compared to the change of the input. So the change of the output is 3, the change of the input is 2. On the graph, does that make sense? That the change between 5 and 8, we have to add 3 to 5 to get 8, and we have to add 2 to -3 to get -1. So that change still makes sense on our graph. And the scaling, it looks like I could have made it a little bit better. So hopefully you guys can reflect that in your own drawings as well. All right. The next step, once we decide that the slope makes sense with our drawing, we're going to now use the slope-intercept form, which is y equals mx plus b. And remember, I told you guys that I want you to start using this phrase for y equals mx plus b. So in class, when I ask about what type of form, you're going to say the slope-intercept form. You're not going to say, oh, that's y equals mx plus b. It's important that you make that connection. All right, so once we have the slope, we don't have the y-intercept, so we're going to have to actually solve for the y-intercept. We're going to use our slope that we solved for before and one of the coordinates. So it was suggested in class that we use the point 5, -3, but it doesn't actually matter which point you use. Substitute in the slope, substitute in an input. Now, do not use 9. 9 was an approximate that we can use to check our work at the end. We have to use the actual y-intercept in our equation. This is just an estimate. So, let's do the math and solve for b. Multiply the numerators, multiply the denominators, add 9/2 on both sides. When we add 9/2 to 5, we need to make 5 have the same denominator. And so, instead of 5, we're going to write 10/2. So 10/2 plus 9/2 is equal to 19/2, which is equal to b. And so our y-intercept is 19/2. 19/2 is 9 and 1/2. So we are really close to our original approximate, which was 9. Next, we're going to take our y-intercept and we're going to take our slope and then we're going to substitute it back into the slope-intercept form. This time, we don't need to use the points because we have the y-intercept and we just want the general form for our final answer. Now, we could use our equation to solve for other parts of the line. Let's do one more example. Let's say that we wanted to write the equation of 2 points, 2, 3, and 4, -2. We're still going to write the equation. I'm not going to actually write out the instructions here because we know we want to write an equation. Plot the 2 points. 2, 3, and 4, -2. Draw the line. Now, estimate the y-intercept. So if this was 3, that might be about 6. The slope is negative. The y-intercept is approximately 6. We're going to use these values later on. First, we need to find our slope, the change of the outputs compared to the change of the inputs. And in this case, since we have a negative in the denominator, we want to move that to the numerator because remember I told you guys that it was much better if we just decided that the slope was always going to be, a negative slope was always going to have a decrease in the output. So again, we got a negative slope, so that matches up with our observation over here. Now, we can also just do a quick check on the graph that in fact the difference between 3 and -2 is a decrease of 5, and the difference and the change between 2 and 4 is an increase of 2. So that also fits our graph. We're still good. Now we have to use the slope-intercept form and one of the points up here. I'm going to go ahead and use the 2, 3, and I'll show you why. Look what happens when we substitute in our point 2, 3 into the equation. Notice that the 2 in the numerator will cross out with the 2 in the denominator, and it makes our life a lot easier. Then all we need to do is add 5 on both sides, and we get that 8 is equal to b. 8 and 6, that still is close enough as an estimate. A bad estimate might be if we said it was 3, which I hope you wouldn't say that because 3 is your output. Or maybe if you said 20, that would be way more than 6. Or if you drew your line the opposite way, maybe you might get like a -6. Then you knew that either something is wrong with your drawing or something is wrong with your math. So these need to kind of be really close, and they both need to be the same signs. So we have that our slope, our y-intercept, is 8. And so now we're going to take the slope-intercept form, and we're going to substitute in our slope and our y-intercept. And now we have the equation